The topic that I'm going to discuss or share with you is still on equilibrium of rigid bodies, but with emphasis on two-force and three-force body. Okay. Equilibrium of a two-force and a three-force body. A particular case of equilibrium which is of considerable interest is that of a rigid body subjected to two forces. Such a body is commonly called a two-force body. It will be shown that if a two-force body is in equilibrium, the two forces must have the same magnitude, the same line of action, and opposite signs. Okay. For example, you have this one, this figure. So if this plate is to be in equilibrium, the sum of the moments of F1 and F2 about any axis must be zero. Okay. Equilibrium man. Okay, so first, we sum up moments about A. Teka, sum up yung moment about A. Since the moment of F1 is obviously zero, kaya it will pass through A, so zero siya. The moment of F2 must also be zero. Okay, wala naman lain mo counter ani. So the moment of F2 must also be zero. And the line of action of F2 must pass through A. Okay. If the line of action of F2 passes through A, there is no perpendicular distance. And moment is force times distance man. And since dili zero ang F2, so dito lang ang pwede ma-zero. If 2 times dito perpendicular distance is equal to 0 man. So if dito is 0, it means that F2 passes through A or ang niya line of action passes through A. Dito is 0. Same also, if you sum up moments about B, the line of action of F1 must pass through B. This one. Initially mo ng F1. Pero, dapat ang moment of F1 about B is 0 also. Kaya ang F2, 0 man. Ang moment sa F2, 0 man. So, the moment of F1 must be 0 also. And since if F1 cannot be equal to 0, so ang distance niya, perpendicular distance niya must be 0. It means na the line of action of F1 passes through point B. Therefore, both forces have the same line of action. This one. From either of the equations, if you sum up forces along X, 0 siya. Same ang magnitude, same direction. So, if you get the X component, positive, kay right. X component left, same magnitude. So, 0. Same with Y. If you get the vertical component, upward. Vertical component, downward. So, makancel siya. So, it is seen that they must also have the same magnitude but opposite signs. So, this is the condition for an equilibrium of a two-force body na dapat same magnitude, same line of action, but opposite in direction or opposite sense. Another case of equilibrium that is of great interest is that of a three-force body. So when you say three-force body, it is a rigid body subjected to three forces, or more generally, a rigid body subjected to forces acting at only 3 points. Three-force body. Now, consider a rigid body subjected to a system of forces which can be reduced to three forces, F1, F2, and F3. Acting at A, B, and C, respectively shown in the figure below. Okay, this one. F1, F2, and F3, acting at points A, B, and C. It will be shown that if the body is in equilibrium, the lines of action of the three forces must be either concurrent or parallel. This one. Okay, what happens to the middle figure? Ayan isa. Okay. Now, if you will sum up moment at A, you have to announce, di ba? F2 and F3. Okay. Consider na known ang distances. If you sum up moment at B, announce at ang F1 and F3. And if you sum up moment at C, announce at ang F1 and F2. So every time you use in an equilibrium condition, you have to announce, di ba? So what are you going to do so that you will only have one unknown? So what you will do is you extend the line of action. Example, you extend the line of action of F1 and F2 so that they will meet at point D. Okay? Sa D ka mag-moment. Instead na sa point A, B, or C. Dali ka na mag-moment sa D. And if you sum up moment at D, 0 ang F1, 0 ang F2. Okay? It will pass through point D. So the only force that can produce movement is F3. So sa motion of movement sa D, you will only have F3 times distance niya, D3, equal to 0. And since F3 cannot be equal to 0, D3 ra ang pwede ma-0. So if D3 is equal to 0, it means na the line of action of F3 will also pass through point D, this one. So you have to reorient F3 so that it will pass through D. So that if you sum up moment at D, 0 tanan. 0 ang sa F1, F2, F3. Equilibrium siya. So this is what we are going to do sa three-force body na analysis. We have to find the point of concurrency where the three forces will meet. And then we can use force polygon there because we only have three forces. So if we use force polygon, mag-close ya. We can get a triangle. We can draw a triangle. Okay. Same na siya sa equilibrium of a particle na concurrent system na. Okay. Okay. So since the rigid body is in equilibrium, the sum of the moments of F1, F2, and F3 about any axis must be 0. So if you sum up moment at the 0 ang moment, kaya mo agi man ang kwan. The line of action of the three forces passes through point D. Okay. Okay. Again, we have to remember this na in analyzing three-force body problems, always find this point of concurrency where the three forces will meet. Okay. First problem. One end of rod AB rests in the corner A, and the other end is attached to chord BD. Yeah. If the rod supports a 40-pound load at its midpoint C, find the reaction at A and the tension in the cord. Okay. So first, we draw the free body diagram. So i-cut na to ng cable and replace this one by tension. And then we also have the reaction at this. Rough surface. So cut na. Okay, we have this one, tension. And then sa A, we have two components. Okay. Dapat, when you analyze a rigid body, we have three unknowns. Okay, we have three conditions man. So, unknown number 1, unknown number 2 is EX and AY. Now, three-force body man eh. So, we have four forces. Instead, we get the resultant of this reaction, RA, so that we'll only have three forces. Now, the advantage of three-force body analysis is the two forces have known line of action. Like ni TBD, momon iyang kwan, momon iyang line of action, di ba? Ang weight sa vertical mo ginasa. So, that's the advantage there. So, since known ang line of action sa two forces, i-meet na, ipa-intersect niyo ng duha. Okay? So, kana, also, diri sila mag-intersect. Therefore, ang resultant ani RA must also pass through this point, RA. Okay? Para equilibrium siya. So, kana, mo na itong RA. Okay, so, na-replace na nato ang components by RA. Diri siya mo agi. Okay? Pwede na din ka mag-force polygon. 3 forces. So, you have 40 and then RA, TBD. Okay, so you can place 40 here para maka-form sa triangle. So, marami ba? 40 RA, TBD. Ano? Okay? So, once na natin sides, 40 RA and TBD, next na to is ang angles. Interior angles of the triangle. So therefore, we have to find the direction of RA as well as TBD. Okay. So, this one. Okay. First, we solve this. Okay. Now, 5 money. Because 10 man, di ba? 10. Now, 12 o 12 man. So, by symmetry, if this is 10, tapos 12 and 12 na 5 nisa. 5 inches. So, we can get the direction of RA kay 5 plus 18 man eh. So, naatay 23 and 12. Diba? Okay. So, we can solve for alpha. Okay, 23 over 12. And natay alpha na 62.447. So, okay na yung alpha. Next. Sige. So, a forced triangle is drawn as shown. In its interior angles are computed from the known directions of the forces. Using the law of sines, we write. Sige. Muna ang 40. And pwede ra ka diri mag-RA and then TBD. Pwede sa TBD and then RA. Depende lang. Okay, sige. TBD and then RA. Okay. Now, this one is alpha. Okay? The direction of RA from the x-axis, it's alpha. 62.447. Okay. Ang next layon is, okay, this one. Consider this right triangle, 90 man. So this one is 90 minus 62, this one. 27.553. Okay. Next, this angle. Okay, so this one. Ma-solve man kay 10 man na. 10 over 24. So you can solve for phi. 10 over 24. So tangent phi 10 over 24. Phi is 22.62. So 22 ano siya? 0.62. Kini po siya. Okay, this one. 90 minus 22. 67.38. So ma-solve nimo kay 22 man sad ni. 22.62 plus this one, i-add nimo, that would be 85. Or simply, 180 minus this one, and then this one. Naka 85. And gamit ka og sine law of sine. RA over sine 67.38 equals TBD over sine 27.553 equals 40 over sine 85.067. So combine this one, RA and 40. You can solve for RA. Cross multiply ni mga sine 37 dire na kay RA. Ang direksyon niya 62.447, this one, alpha. 62.447. To solve for BD, kanana sa sila duha, cross nini mo, i-cross multiply sa right, and we have TBD. Ang angle sa TBD, ang iyang direction is 22.62. Okay. Ingon na ni ang three-force body analysis. Okay? First, extend mo ang line of action sa two known forces, and then after that, i-direct nimo ang third force that will pass also that same point. And then compute for angles and distances, and then construct a triangle, and then sine law, and then you have the unknown forces. Okay. Another one. Rod EB is supported by a pin and bracket at A, this one, and rests against a frictionless peg at C. Now, we already have discussed this one sa katong support ba? Peg sa part 1. So, determine the reactions at A and C when a 170 Newton vertical force is applied at B. So, this is our rigid body. So, ato yung i-cut and then isolate na to. Ang unknown forces na to, we have RC. Now, the reaction at C is perpendicular sa ACB na member. Okay, rad EB, rad EB. Perpendicular. And then you have RA and then RB. Now, if you will not use three-force body analysis, katotang condition ta na summation of force sa X, summation of force sa Y, summation of moment, pwede. Bale, since ma-compute nimo ang direction na ni kay 300 over 160, you can compute for this angle, di ba? Ma-compute nimo ning angle. So you can resolve this inclined force into X and Y components. Pwede ra. No? Bali ang equilibrium, ang three-force body analysis is an alternate solution na if possible, we do not use equilibrium conditions. Like the previous problem, we didn't use any of the three equilibrium conditions. Diba? We only computed angles and distances, and then we constructed an oblique triangle, and then we used sine law to solve for the forces. That's the intention sa three-force body. Okay. Instead na, we sama force sa X, sama force sa Y, and sama moment. Okay. So, ang known line of action is this, 170 and then RC. So, extend na to. And then this one, dili sila mag-meet. So, ang RA, we are going to replace this one by its magnitude. So, dapat ang line of action sa RA will pass also this point. So, i-replace ito na by RA. Okay? And then from here, construct a triangle and then solve for four angles. So, to form a triangle, you can put 170 there para mag-close yung triangle. So, 170 RC and then RA. 170 RC RA. Okay, so we compute for angles, direction sa RC and direction sa RA para sa atong triangle natin. We can solve for alpha. This is 300 and 160. So, tangent alpha, 300 over 160. 61.9275. So, okay. So, ang atong phi is actually 90 minus alpha. Okay? So, 90 minus 61 is this one. 28.0725. Now, this is phi also. Okay. This is a right triangle, man. So, 90 eh, yeah? So, if this is phi, then this angle is 90 minus phi. Therefore, phi. So we already have the direction of RC from the horizontal, which is phi. Okay na. Okay. The only problem now is the direction of RA from the horizontal or vertical. Okay. Let's compute this one. Para to solve for this angle, the direction of RA or this one, same lang RA, need mo na ito in a distance. This one is 160. No problem. Kaya na lang. Pila na siya nga distance. So first, we compute this distance. Now, by symmetry or by ratio and proportion, ang position, ang location sa C, nasa middle. Kay 150 mo na and then 150. Therefore, pag i-cut ni mo, 160 man, this is 80 and then 80 sa ni. Okay, half man, sana sa midpoint yun. 150 and 150 man. So, since 160 ni, so 80 sa nila. So, we have 80 and then we have phi. We can compute this one. Tangent of phi, y over x. So therefore, y is equal to x tangent phi or ET, okay, ET or x tangent of phi, which is 28.0725. The value is 42.6667. And from here, we can compute for this distance. That's 150 minus this. And it's equal to 107.333. So we can now compute for this angle or this one. Beta. So tangent beta is 107.333 divided by 160. This one. So we have beta na 33.855. So we now have the direction of RA from the horizontal. So ready na ta mag-construct og triangle or force polygon. So force polygon. You start with 170 and then RC, this one RC and then RA. And then RA. Okay? And then interior angles. Sige. Direction of RC. Phi, di ba? 28, no? Direction of RC from the horizontal, it's 28.0725. Therefore, we can compute this one, 90 minus phi. 61. Okay. Sa RA side, kini, beta. Beta na siya, which is 33.855. Na-compute din na to. 90 minus this one. 56.145. So, known ang duha, we can solve for this one. 180 minus the two angles. We have 61. Pwede na dahil ka mag-sine law. Okay, RA over sine 61.9275, RC over sine 56.145, yeah, 170 over sine of 61.9275. Combine RA and 170, cross multiply ang 61, sine 61 rather, and na kay RA. It's actually, if you look at this one, isosceles triangle, okay, same yung angle, 61.9275, 61. Therefore, kini na side o kini na side equals at kay same ang base angles. That's why ang atong RA 170. And then RC and 170 combined. The result is 160. And this is the angle. RC. 28.0725. So, Yung nani ang three-force body na analysis. If possible, do not use conditions of equilibrium like summation of moment. Dili. Manipulate angles and distances para sa triangle nimo. Para sa interior angle sa triangle. Another one. For the frame and loading shown, determine the reactions at A and C. Now, duwa ni siya ka rigid body. EB is actually a two-force body, no? Two-force body siya because ang forces nga nag-act ani is nasa A o nasa B man. So you only have two forces. Bali, i-separate nimo ni siya if possible. You can separate, pwede po dili. Bali, if you will consider BCD, you will only have three forces. Force sa B, reaction sa C, and then 30. Three-force body. Pero, we can also combine this one para three-force body analysis lang yapon. Okay. So, this is our FBD. Since two-force body ang AB, no other forces man. Force A and force B naman. Two force bodies. Therefore, collinear siya. Okay. Collinear. But still, we don't have any idea kung ang force A is second quadrant ba and fourth quadrant. Pwede sad na ang sa A is fourth quadrant and then ang B is second quadrant. Just make sure na opposite ilang direction. Okay? Now, this is RA. Wala pa tayo arrowhead, just this line, RA. So, known yung direction. Dire, 45 degrees. Okay. 45 kay, ano man siya? 3 og 3 man. Di ba? Quarter of a circle man siya. 3 og 3, so 45 siya. So, i-extend na to, i-extend na to ang RA. Extend, and then extend on. Diri sa mo agi ang reaction sa C. Diri man ang point of intersection sa duha. So, ang reaction sa C, diri sa mo agi. Okay. Mo din mo RA. So, kung mag-form ka og triangle, pwede ra nga ang nadiri ang 30, 30, 30, RA, and then RC. Okay? Para mas dali siya ma-visualize ni mo yung triangle. RA, 30, downward, 30, RA, and then RC. Okay, so, okay na ta sa first polygon, angles na lang. Sa sides, okay na ang sides, angles na lang. Now, if this is 45, okay na ang RA. 45 man. The only problem is RC. The direction of RC. So, if you want to solve this distance, this angle, we need this distance. Kaya na naman tayo 6. So, okay na lang. But we have 45 degrees man. Kaya 45 man so 45 ni. So, kung 10 siya, 10 siya ni. Di ba? Kaya 45 degrees man, equal man na. So, 10 siya, 10 siya na. And ma-solve niya na to. Kana, theta. Tangent sa theta, that's 10 over 6. So, arctan, the result is 59.04. Mo na ang direction sa RC. From the horizontal, 59.04. Nara, 59.04. Okay. Since known na ang direction sa RA and RC, we can now construct the force polygon. Okay. So we have 30, and then 30, 30, and then RA, and then RC. RA, and then RC. Okay. So obvious na ang RA is this way, fourth quadrant. Ang RC is second quadrant. Okay. Angles na yun. This one is 45, di ba? Direction of RA, this one RA, that's 45. And 90 man eh. So 90 plus 45, we have 135. Okay? Next, the direction of RC from the horizontal is this, 5904. Kano yun? 59 na siya. Same money. So 90 minus this, 30.96. And 180 minus the two angles, you have this, 14.04. That's it. Complete na, no? Sine law na yun. RA over sine 3096, RC over sine 135, 30 over sine 1404. Combine RA and 30, you have RA, and then you combine RC and 30, you also have RC. Inana lang. Right? So, yung nani ang three-fourths body analysis. This is how you analyze three-fourths body na problems. So, you start with two forces with known direction. So, in this problem, it's RA and 30. So, i-extend na to. And then, i-direct din na to ang third force that will also namupasa siya na common point. And then solve for angles, and then construct a triangle, and then sine law, and then that's it. So I hope that you have learned something from this topic. Thank you for watching.